You know, what's the one thing that connects an ancient Greek philosopher with the AI in your pocket? It's something we all do every single day: reasoning. Today, we're going to pull back the curtain on how our own minds do it and how we're teaching machines to think in the very same way. We're going to follow that incredible thread, all the way from Socrates to Silicon Valley.
So here's what we're going to cover. First, we'll nail down what reasoning actually is. Then we'll get into the three main ways humans think logically. After that, we'll jump over to the world of AI to see how it's learning to reason. We'll even peek inside the mind of a large language model before we finish up with a look at their limits and what's next on the horizon.
All right, first things first, let's make sure we're all on the same page. When we say reasoning, what are we really talking about? It's not just thinking. It's the very foundation of how we make sense of the world.
At its absolute core, reasoning is just, well, it's connecting the dots. It's how our brain takes information we already have, or stuff we assume is true, and uses it to figure something new out. This is the engine that drives everything, from solving a crossword puzzle to making a huge life decision.
Okay, so now that we know what it is, let's talk about how we do it. Turns out, our minds basically have three main blueprints for building arguments and figuring out what's true.
And here they are: deductive, inductive, and abductive reasoning. Think of them as three different paths our brain can take. They all start with some kind of information, but as you can see, they each follow a totally different route to get to a conclusion. Let's start with the classic, deductive reasoning. This is your top-down logic. You start with a big general rule you know is true, like all humans are mortal. Then you apply it to a specific case. Socrates is a human. The conclusion? It's a sure thing. Socrates has to be immortal. There's no other option.
Now let's flip that on its head. That brings us to inductive reasoning, which is bottom-up. Here, you start with specific observations. You see one white swan, then another, then 100 more. From all that evidence, you build a general rule. All swans are white. But, and this is the important part, it's just probable. It's not guaranteed. Because all it takes is one black swan to show up and your whole theory is blown.
And our third type is abductive reasoning. I like to call this detective mode. You start with a clue, an observation: the grass is wet. Then you work backward to find the simplest, most likely cause. Did it rain? Yeah, probably. Could a sprinkler have done it? Sure. Abductive reasoning is all about making the best, most educated guess you can with the evidence you've got. This table really just nails the difference. When you're making a deductive argument, you're shooting for absolute certainty. If your starting points are true, the conclusion must be true. But with an inductive argument, you're playing the odds. You're building a strong case where the conclusion is likely true, but you can never be 100% sure.
Okay, so that's the human toolkit for logic, right? Honed over thousands of years. But this leads us to probably the biggest question of our time. Can we actually teach a machine to think this way? And that question takes us right into the fascinating world of artificial intelligence, where some of the smartest people on the planet are trying to translate these deeply human processes into code.
So what is AI reasoning, really? It's the mission to build systems that don't just compute, but can actually make inferences, draw conclusions, and solve problems, pretty much like we do. The goal here isn't just about crunching numbers, it's about understanding context. And the technology that's absolutely at the bleeding edge of all this is large language models, or LLMs. I'm sure you've heard of them. These are those massive AI systems that have been trained on just an insane amount of data, and they are starting to show some truly mind-blowing reasoning skills.
So let's pop the hood. Let's really get into how these things work. What is actually going on inside an LLM that allows it to mimic the way that we think?
What's just wild is that LLMs are getting good at all of this stuff. They can tackle logic puzzles, they can apply what looks like common sense, they can do math, figure out cause and effect, and even do that detective thing, making educated guesses. And the craziest part? These aren't skills that were hard-coded into them. They're abilities that have emerged from their training.
So, how do they pull it off? Well, it all starts with pattern recognition. They learn to see complex patterns in all that data they're fed. Then, they use something called in-context learning, which means they adapt on the fly to the information you give them. But the real game changer has been this technique called chain of thought prompting. That's where things get really interesting.
Chain of thought is basically like telling the AI, hey, don't just give me the answer, show your work. When you force the LLM to actually break down a problem and explain its thinking one step at a time, it gets way better at reaching the right conclusion. And that's the whole idea right there. You're guiding it, pushing it to think in a more structured, deliberate way, just like a person would if they were tackling a really tough problem. That little bit of guidance helps keep it from making silly mistakes.
But let's be real for a second. This technology is incredible, but it's not magic, and it's definitely not perfect. We have to take a hard look at its limitations and see where we go from here.
And there are some pretty big challenges. For one, an LLM has never touched grass. It has no real-world experience. It just knows patterns in text. That also means if the data it trained on was biased, the model will be biased too. And sometimes its reasoning is a total black box. It gives us an answer, but we have no idea how it got there.
The good news is researchers are all over this. They're working on new ways to prompt these models, trying to connect them to external sources of truth, and probably most important of all, they're trying to make their reasoning more transparent so that we can actually trust the answers they give us.
Which leaves us with the big critical question. As these AIs get better and better at reasoning, the challenge for us is no longer about if they can think. It's about how we can verify their thinking and build systems that we know for a fact are reasoning accurately, responsibly, and without bias.